So our goal in this part of section 10.4 is to start out with an equation like this and complete the square to make it look like this. The advantage of having it like this is that it's easier to graph, right? You can pretty much read off the vertex. So we need to play around with this a little bit. Now there's a variety of ways you can do this. Let me show you the one that I think works the best. I'm going to start by moving that 5 to the left-hand side. So I'll just subtract 5 from both sides. And now I want to complete the square in this because I want to get a nice squared term here. And I'm hoping you remember this from the other day. I need to come up with a number that makes the right-hand side a perfect square. So do you remember the process involved in doing that? Half of the middle term is 3. 3 squared is 9. So I'll add in a 9 there. But it's not enough just to add a 9 to the right-hand side of the equation. What else do I have to do? Add it to the left. So we'll add it to both of them. On the left-hand side, I end up with y plus 4. On the right-hand side, this is now a perfect square. So how can I write that? What would they be? What do you square to get x squared plus 6x plus 9? X plus 3. Yay. Last but not least, let's get y by itself again. So I'll move that 4 to the right-hand side. So there's x plus 3 squared minus 4. Yay. Greg.
How'd you go y plus 4 from that?
Negative 5 plus 9 gave me the 4. So these are just like terms. I just combined them. Is that good? Right here. So when I added 9 to both sides, I had a y minus 5 plus 9. These two terms here combine. That's all I did. Anything else on 44 here? Now, one of the requirements when you complete the square, and it's something we haven't had to deal with yet until now, is that this coefficient here in front of the squared term is a 1. We can't do our little trick of half this number and then square it unless the coefficient of your x squared term is a 1. And that's not the case in problem number 54. So we've got f of x is negative x squared plus 6x minus 8. F of x is equivalent to y, so let me rewrite that as y is negative x squared plus 6x minus 8. And I'll start out by doing the same thing I did with the last one. I want to get these terms by themselves. So let's add the 8 to the other side. Y plus 8 equals negative x squared plus 6x. And here's where I run into a little snag. Out in front, I don't have a positive 1. I've got a negative 1. So I've got to do something about that. And my suggestion would be to factor out that negative 1. So if I factor out that negative 1, and don't factor out the GCF, don't factor out a negative x, just factor out the negative 1. What's left inside? X squared minus 6x. Good. And you can check it by distributing. That would give me negative x squared, and then negative times a negative is a positive 6x. So these two things are equivalent. But the thing that I got out of that I wanted and needed is that there's a coefficient of 1 inside the parentheses. So, okay, we're good there. That's what we needed. Now we're ready to complete the square on that little piece inside. So this is y plus 8 plus something, x squared minus 6x plus something. You know how in all these big trade deals they go for a player to be named later? This is kind of like our number to be named later. Let's see if we can't figure out what's going to go inside here. This should be kind of a similar calculation to what we did just a minute ago. 1/2 of negative 6 is negative 3. Negative 3 squared is 9. So I'll put a 9 up here, but don't put anything here just yet. What I want to impress upon you is that I'm not going to put just a 9 here. Let's understand why. Yes. If you were to distribute this negative to all three of these terms, you would get a negative x squared plus 6x minus 9. See where that minus 9 comes from? It's because you have to distribute that term out in front. Let's compare this to where we started out. Minus x squared, that lines up. 6x, that lines up. What's the difference between this term and this term? You've subtracted 9. So out in front here, or excuse me, over on the left-hand side, we've also got to subtract 9. You subtracted 9 from the right-hand side by putting the 9 here. You have to do it on the left-hand side. Basically, it works out to this times this gives me negative 9. So I'll add negative 9 to the left-hand side. Combine the like terms here. What's on the left-hand side? Yeah, negative 1. So it's y minus 1 equals a negative of something squared. This is now a perfect square in the parentheses. What do I square to get that? X minus 3. Almost done. The last thing to do is to move that 1 to the right-hand side. I get y equals negative of x minus 3 squared plus 1. You can't because it's squared. If you think about your order of operations, you have to do the parentheses first, and then exponents, and then multiplication. So it'd be a fair amount of work before you can distribute the negative 3 back in. It's a great question, though. What's the vertex of this parabola? Good. 3 and 1. Which way does it open, up or down? Opens down. You can tell that because of the negative. In fact, you can even tell that way back here before we completed the square because you still had that negative right in front of the x squared. So, opens down. Anything else on problem 54 here?
Why is the 3? Why is the vertex 3?
By looking at the squared term. So, you got to ask yourself, well, what makes the squared term equal to 0? 3 minus 3 would be 0. What makes the squared term equal to 0? So basically it's always going to be the opposite sign of what this number is. So if you have a minus 3 here, it's going to be a plus 3. If it was a plus 3, it'd be a minus 3. And like we noted, this one was going to open down. When it's all said and done, you'd have to divide by negative 1 to finish solving because you'd have a negative y on one side instead of the positive y. So it would work, but you know, in this case, it is kind of a quick fix just to move things to the other sides and then maybe take care of the negative at the end. But when you get to a problem like 46, it's going to get a little bit more challenging still. So I'd stick with just factoring things out. And let's take a look at what problem 46 has to offer to see what I mean by that. I appreciate the question. Thank you. So 46 is f of x is 3x squared minus 12x plus 10. And as with all these, I prefer to write a y here. Where should I start? What do you think? What would be a good place to start? Sarah? Yeah, subtract 10. So y minus 10 equals 3x squared minus 12x. That's good. But, kind of stuck here a little bit. I can't complete the square because that's not a 1. It's a 3. So what should I do? Factor out the 3. And just the 3. Do not factor out 3x. I know that you're well conditioned to factoring out the GCF. Just want to factor out the 3. All right. So that leaves behind x squared minus 4x. Now we're going to complete the square. Kind of the same process that we've done several times here. What number do I put in the parenthesis to complete the square? It's always going to be a plus. So 1/2 of negative 4 is negative 2. Negative 2 squared is 4. Great. Anna, if I put a 4 in the parentheses here, what do I have to add to the left-hand side to keep it in balance? Well, what's we got to look at the. I really didn't just put a 4 here. I put 3 times 4 on the right-hand side. So 12. So you put 12. By putting that 4 there, you've added 12 to the right-hand side. So to keep things in balance, you're going to add 12 to the left-hand side.
Is that because 12's up in the problem?
No, it has nothing to do with the 12. It has to do with the fact that 3 times 4 is 12. That's all it has to do with. Yeah, so to figure out what to put on this other side, it's always going to be this number times this. That's what you put on the right-hand side. That also worked on the last one. Negative 1 times 9 is negative 9.
Okay, I didn't see that last one.
It's all right. I'm glad you're catching it now. Let's clean up each side. On the left-hand side, negative 10 and 12, that's a 2. What do I square on the right-hand side to get x squared minus 4x plus 4? X minus 2. Last but not least, let's move this to the right-hand side. 3 times x minus 2 squared minus 2. Nice. How are we looking on that one? You ready to try one? Yes. Okay, looking good? Thank you. All right. Is there anything else, any little detail on this last one before I give you problem number 50? So what I do on an exam is I make this its own problem. I'll give you something like this and I say, all right, put it in this form, and that'll be its own problem. A separate problem would be to take something in this form and graph it. And the reason I do it that way is because if you screw up the first part, you still might be able to do really well in the second part. But not if you don't have the right answer from the first part. So I make them separate problems. So count on this being a problem for an exam. Y equals negative 2x squared plus 4x plus 3. So this one's yours. Give that one a shot, see what you can do. If you need some help, let me know. And here's our high-tech pause. So when you're watching this at home, you know to fast forward the video until I take this away. I understand the IT department's like, no, we don't have $800 to spend on this, but we gotta do this. Until the software is configured, I don't have a pause button.
4 minus 3.
To get rid of it from this side, you're subtracting 3. Oh, you don't want to factor out the negative until you get rid of the 3. Get rid of the 3 first. Start out by moving this to the side right away. And then take care of that. Okay.
This is no fun.
Okay. Start out by getting the x's by themselves, so it's y minus 3 equals negative 2x squared plus 4x. I can't complete the square because the coefficient is something other than 1. So I'll factor out just the negative 2. Don't factor out the GCF. I know it's tempting, but don't factor out the GCF. Factoring out the negative 2 leaves behind x squared, and then what else? Minus 2x. Remember that minus 2 has to divide both of these. 4 divided by minus 2 is minus 2. How could you check it? What's a real quick check on the fact that these two things are equivalent? Distribute it. This times this gives me negative 2x squared. Negative 2 times negative 2 gives me positive 4. So y minus 3 plus something equals negative 2 x squared minus 2x, again, plus something. And let me kind of stay consistent here. We're going to take half of that middle number. Half of that middle number is negative 1. Negative 1 squared is 1. So I'm going to put a 1 up here. What does that mean I put over here on the left-hand side? Negative 2. And that comes from negative 2 times 1 is negative 2. So the left-hand side is y minus 5. The right-hand side is x minus 1 squared. Nathan, I should have asked you that one. All right. Last but not least, let's move that 5 to the right-hand side. We get y equals negative 2 times x minus 1 squared plus 5. Now, one thing you could do if you're really desperate on the test and you're like, I need to get this thing right. I need to know I have that thing right. One thing you could do is actually graph both of these. You can start out by graphing this one, see what it looks like, and then graph this one. These should give you the exact same graph because there are two different versions of the exact same equation. So you can check. Another easy thing you could do to check it, make sure they at least give you the same y-intercept. How do you find the y-intercept? Set x equals 0. That's pretty easy up here, right? 0 plus 3. So the y-intercept of 3. Down here, a little bit more work. 0 minus 1 is negative 1. Squared is positive 1. Negative 2 times positive 1 is negative 2. And negative 2 plus 5 is 3. So at least it gives you the same y-intercept, and there's good hope that maybe the rest of it's right. Probably be really unlucky if that checked and you still had it wrong. Okay, how are we looking on that one? Good? Thumbs up? For homework, try 21 through 37 and 43 through 53. That's section 10.4. Now there's other things that aren't in the video that you're going to see with this one, but there's a whole other video online for this section. Have a great weekend. See ya. Yes.